1. The spinal stretch. Straight to the point. Your body is about to get wrecked. I'm talking about a total overhaul that starts within your first few weeks on Mars. See, on Earth, gravity is constantly dragging you down at 9.81 meters per second squared. Every single second your whole life, that weight has been crushing your spine, mashing your inner vertebral discs like they're cheap rubber bumpers. But Mars, you've only got 38% of that load. The theory of spinal decompression tells us exactly what happens next. Your spine stretches, no constant pressure. The discs just swell up. They soak up fluid and expand. This isn't some movie script. NASA's already seen it in astronauts on the ISS. We're talking a 2-inch growth spurt almost overnight. For you, that's just a temporary tweak. But over generations, evolution is going to bake that straight into your DNA. The human species is going to mutate. Period. We're looking at an average height well over 7 feet as the new standard. The law of vertebral decompression gives biology zero choice. You'll mutate into this extremely long, spindly silhouette. That's the moment the split from Earth becomes permanent. A body that after enough generations is so adapted to Mars that going home would literally kill you. Your mutated spine would just snap under Earth's 1G load. 2. Vestibular recalibration. So, you're 7 feet tall. Great. Now your brain has to figure out how to actually pilot that lanky frame. Keyword, sensory weighting theory. Your inner ear is hardwired for Earth gravity. Those tiny crystals in your ear. The autoeths usually tell you exactly where down is. On Mars, those crystals weigh almost nothing. Your brain starts getting signals that it basically treats as static. Within days, your brain takes a radical shortcut. It ignores your inner ear and leans almost entirely on your eyes. We call this vestibular plasticity. You'll feel that shift yourself. But the real mutation, that's for the Marsborn. Their actual neural architecture is going to physically change. These 7-foot Mars humans of the future, they won't move like we do. No stomping around, it'll be a series of hops and glides. Through the genetic mutation of the inner ear, they'll develop a completely different sense of space. While you're up there puking from vertigo, the next generation will see 0.38 G as the absolute 0 point. A neurological mutation that allows for agility that looks, honestly, it looks surreal. Why? Because their balance organ has accepted Martian lightness as the only physical constant that matters. 3. Cardiovascular downsizing. Picture it. You're 7 feet tall, gliding around with this weird agility. But while you're doing that, your most important muscle is already quitting on you, your heart. This is the law of atrophy of disuse. On Earth, your heart is a heavy-duty pump fighting gravity just to get blood up to your head. On Mars, 62% of that resistance just vanishes. Medical data is clear. Drop the resistance and the muscle shrinks. It'll happen to you after a few months, but the real evolutionary gut punch hits over the centuries. The species is going to mutate. Future generations will be born with this stick-thin frame and a heart that's genetically downsized. We're talking 20 to 25% less mass than ours. Blood pressure. Your descendants will have a permanent low. They won't need anything higher. Because of this mutation, those venous valves in the legs, they'll genetically wither away. On Earth, those are lifesavers. They keep blood from pooling in your feet. On Mars, redundant. The result is a system that runs perfectly at G0.38 but collapses the second it touches Earth. The descendants of the settlers will be prisoners of their own circulatory mutation. Earth's gravity would be a death sentence for their tiny hearts. 4. The barrel chest. All right, so you've got the 7-foot body and the tiny heart. But it gets worse. Let's talk about the air. Even if we terraform Mars, the atmospheric pressure is always going to be pathetic. This is where Boyle's law kicks in. Lower pressure means a gas needs more volume. To get the same amount of oxygen into your lungs as you do on Earth, your body has to process way more air. You'll start off just huffing and puffing, but over generations something else happens. We see it with Tibetans in the Himalayas. High-altitude adaptation science shows they've developed larger lungs over centuries. On Mars, this goes to the extreme. The human species is going to mutate and grow a massive barrel-shaped chest. The rib cages will widen just to make room for giant lungs. And the blood chemistry, it follows the lead. The Martian body will ramp up hemoglobin production to a level that would be dangerous for us, but up there, it's the standard. A Mars human will be born with a lung capacity that makes them look like an elite athlete, even when they're just sitting on the couch. Evolutionary mutation as a response to thin air. Simple as that. 5. Hypercalcification. 7 feet tall. Tiny heart. Massive chest. Now your skeleton has to keep up. In low gravity, your frame usually gets brittle. You'll feel this as a settler immediately. Your body starts leaching calcium out of your bones and peeing it out. Wolff's Law says bones adapt to the load, no bones. To keep the colony from just crumbling into dust, natural selection is going to get mean. Only those with a mutated bone metabolism will survive long term. Over many generations, the human species is going to mutate. A process will take over that genetically blocks that calcium loss. The body won't throw away the calcium anymore. Instead, the bones stay permanently hypermineralized. This is evolutionary hypercalcification. The skeleton will mutate to become denser. It has to. It's got to support the structural load of a 7-foot-plus frame and a massive barrel chest. The skull gets thicker. The joints get robust. Without this mutation, every little bump would shatter your legs. Future descendants will have a skeleton so dense it would weigh like lead on Earth, a massive insurance policy in the red dust. 6. Hyperactive DNA repair. If gravity doesn't kill you, the radiation will. There's no getting used to radiation on Mars. Not in one lifetime. Your cells either survive or you get cancer and die. That's the genetic filter. On Earth we have the p53 gene, the guardian of the genome. It fixes DNA damage. Science is pretty certain only people with a lucky hyperactive mutation of this gene will live long enough on Mars to have kids. Over centuries, the human species will mutate toward a genetic firewall. Cells will patch DNA breaks almost in real time. This is the p53 guardian theory in its final mutated form. This is pure evolution. The Mars human of the future will mutate into a biological fortress. It's not an option, it's a requirement. You don't develop this genetic strength. You're out of the gene pool. The result is a species that's more resistant to cancer than anything we've ever seen. 7. The radiation tan. While the cells are fighting on the inside with a p53 mutation, the skin is building a shield on the outside. This isn't a tan you get after an afternoon in the sun. The theory is based on the biology of carotenoids. We know certain life forms use carotenoids to block radiation. Instead of just making melanin, the gene pool on Mars will mutate over centuries to store carotenoids directly in the skin. Radiation protection pigmentation theory. These pigments filter out high-energy photons. The result is a wild mutation of appearance. Your skin will be genetically deep orange or rusty red. This orange skin is the natural sunscreen of the Marsborn, a mutation that digs in over generations until being human on Mars is inseparable from being orange. Combined with being over 7 feet tall with a barrel chest and bird legs, the Homo Martis already barely looks like an Earth human. 8. The owl eyes. So, we have a 7-foot orange human with dense bones and a genetic firewall, but Mars is a long way from the sun. The light is weak. The inverse square law applies here. You'll need a lot of artificial light at first, but evolution takes a different path long term. Over generations, the retina will mutate. The density of rod cells, the ones for seeing in the dark, will skyrocket. This is the theory of retinal adaptation through selection. At the same time, the pupils of future generations will be genetically wider. The eye of the Homo Martis will mutate larger, darker, deeper. This mutation turns them into perfect creatures of the twilight, almost like owls. The Marsborn will see details in the dust that are invisible to you. But this mutation has a price. It locks them out of Earth. A summer day on Earth would be a blinding nightmare for those mutated eyes. The human species will mutate into creatures of the gloom. 9. The decelerated metabolism. Energy is the hardest currency on Mars, mostly because of what you'll be eating. Forget steaks or fresh apples. According to the theory of trophic levels, raising livestock on Mars is energetic suicide. Too many resources for too few calories. Your diet will be based on 3 things: in vitro lab meat, insect protein like cricket flour, and algae cultures like spirulina. This stuff is efficient, but it's optimized at a molecular level. Here's where resource efficiency theory comes in. When food is strictly rationed, a high calorie burn is your death warrant. Over future generations, the human organism will mutate to deliver max performance on minimum fuel, space fuel for a mutated body. Body temperature will drop. Heart rate will slow even more. Digestion will mutate to process concentrated proteins with zero waste. The human species will mutate into a biological eco-mode. Scientifically, creatures with slower metabolisms often live longer. It's very likely that Mars humans will live much longer than we do because of this mutation. A life lived in slow motion. A genetic answer to a planet that doesn't forgive waste. 10. The return of prehensile feet. At the end of the chain, after thousands of years, comes the total change in your mobility. In a 7-foot-tall body with orange skin, owl eyes, and a slow metabolism, the Earth foot is just a hurdle. On Earth, your foot is a rigid platform for walking. On Mars, in low gravity and tight habitats, you need more grip. Theory of habitual adaptation, morphology mutates. We see it today. Astronauts use their feet like extra hands to hook into things. If you live like that for millennia, selection will favor toe mobility. The foot will genetically mutate into a prehensile organ. Atavismus theory, the return of the gripping functions of our ancestors. Longer toes, a more mobile thumb toe. The line between hand and foot will slowly blur in the Homo Martis. There'll be creatures moving through space like acrobats with gripping feet. The floor is just one of many surfaces for them. This isn't some movie script. This is the cold logic of biology under Martian conditions. When we leave Earth, we give up our identity as Homo Sapiens. Mars doesn't ask if we want to change, it forces us. If you enjoyed this look into our Martian future, hit like and subscribe. Don't miss the next episodes. Thanks for watching, stay curious, and see you next time.